Partial fractions is a way to rewrite a fraction into partial fractions. And the way to do this is to actually figure out how to factor the denominator and use that as two denominators with the partial fractions. So when you factor this, you would see that it's going to look like this, and these two denominators are the same thing as those factors. The question is, how do you get the 2 and the -1? So the way that we're going to do that is to set variables for 2 and -1, a and b, and then set the numerators equal to 3x minus 1. For example, again, first thing you do is factor the bottom, and let's see, one's plus, one is minus, and so this is going to be -4 and +3. And so I know that this is going to equal some a over x plus 3 and some b over x minus 4. Now, I know that if I make these bottoms the same as this bottom, then the tops have to be the same. So in other words, if I multiply the top and the bottom by x minus 4 here, the bottoms will be the same, and the top will be left with a times x minus 4. Similarly, here I'm multiplying by x plus 3 on the top and the bottom, so it's plus b times x plus 3. And the numerator is going to equal this. Now, the bottoms would be equal, so the tops would be equal now too. And now you want to solve for your a and b. Well, how do you do that? You would expand the right side, so it's going to be ax plus bx, and so I'm just going to go ahead and distribute through. And now I want to group my x's together and my numbers together. So my x term, it's going to be a plus b times x. And then it's minus a times 4 plus 3b. Now, that's where you can make two equations. Your x coefficients are the same. In other words, a plus b must equal 5. And the other part of this is negative 4a plus 3b equals negative 34. Now, at this point, you have a choice. You could use matrices to solve for a and b, but normally they're relatively easy to solve for. So if I change that first one by multiplying it by 4 on the top and the bottom, I'm sorry, the left and the right, and then adding the two equations, I'm doing a system, a linear combination system here. I'm going to see that 7b equals negative 14, so b is equal to negative 2. If I know that b is negative 2, I can see that a is equal to 7. And therefore, the partial fraction would be 7 over x plus 3 minus, so it'd be plus negative 2, or minus 2 over x minus 4 by substituting in the a and the b. And so this would be the partial fraction decomposition. Now, why would you do this? The reason why you would break it down into denominators with linear factors is because it's something that you can do in calculus called differentiation. So you'll be able to differentiate this much easier than you could differentiate this. So the reason really isn't unclear at this point, but we just want to give you some exposure to breaking down a fraction into partial fractions, and and also possibly applying matrices in the process.